So tonight we have Karen Donoghue, and she'll be talking to us about interactions at scale for monitoring air. So thanks everybody for coming, and I will turn it over to Karen.
Okay,
Okay.
thank you so much. Thank you so much, Joe. I'm really thrilled to be here. I'm so excited to talk to you. Thank you to Rachel and to Aditya and to Joe and to everybody tonight for showing up. I'm really happy to talk to you. I'm going to talk about some of my work on air quality monitoring. We're going to talk about an application I've developed called Local Haze. It monitors over 30,000 air quality sensors across 6 continents, and it's designed to be really easy to use. And we'll do a Q&A if you want to submit your questions into the chat, and I'll answer them at the end. I'm going to go quickly through the material. I have a lot of material to show you, and I'm really excited. Okay, so what we're going to cover tonight is we're going to talk about what it means to monitor air quality at scale. That means lots and lots of entities in terms of geographic scale or number of entities, but we're also going to talk about temporal scale, that's time-based scale. What does that mean in terms of some of the challenges of designing a great user experience? And also, we're going to talk about what it means to design for citizen scientist users. Those are particularly unique kinds of users. They're motivated to monitor their air quality, they want to understand it, but they're not necessarily technical people. And we're going to also look at other impacts of scale when you're designing these data intensive experiences that have to be delivered, in our case, on a device and have to have real-time performance and be connected to a network. And what does that mean in terms of all the challenges? So everybody maybe knows my name, Karen Donoghue. I'm a longtime HCI practitioner. I'm from Boston. I've founded my own practice called Human Logic after a long career in technology. I've worked mostly in software development and platform design for connected devices. This is my second book I just published with Craig Newell on user experience for founders. I also wrote another business book on user experience in 2001 with McGraw-Hill in New York. I'm a Media Lab alum from MIT and also a Tufts CS alum. So if there's any Tufts CS alums, I hear there might be some in the audience tonight. I'm excited. So the companies, some of the companies I've helped, this is a small selection. These are range from very, very large companies, done projects. In some cases, I've been an employee. I was a member of the design team at Motorola. And some of the devices, really focus a lot on connected device platforms. So on the far left is the Savage platform. That was a full stack Java implementation of a mobile platform. Excuse me. This is the Razor 2. You may remember that device. I worked on the Linux operating system to enable the device experience. Interesting form factor because it's a flip phone and you have 2 monitors or 2 displays, one on the back and one when you open the device. This is a Misalu keyboard. It's a 2-octave keyboard that when you plug it into an iPad, turns it into a MIDI device. This is a wireless picture frame, so touch sensitive, where you can customize your experience. And this is a robot for stroke patients and to help them with their neuro rehab, but also to help the therapists who treat them, because a lot of times the therapists have to go through so much repetitive work with their hands that they develop a lot of carpal tunnel syndrome and other injuries. So that was a really exciting project. And on the far right is Local Haze, which is what I'm going to show you tonight. So Local Haze, which is free, you can download it on the App Store. I put the link in the chat. The use case is, it answers the question, is the air okay enough for me to go outside, or can my elderly mother go take a walk, or can my kids play soccer outside? And in my case, I was motivated because I was subscribed one of these, or prescribed an inhaler for asthma. And I was told that I had to carry it with me everywhere. And I began to think about, what's in my air, or what is it in the air that I'm breathing? And how can I create an experience that anyone can understand at a glance in a way that's easy, does not require a lot of technical expertise, and also is beautiful? So you can see on the right, I've always been striving with all of our releases to do something that's easy, beautiful, and understand something about what people want. So in this case, we have representations of the air quality by color based on the air quality index. I'll show you that. and then a confidence badge, which tells you the confidence level for that particular reading. And then also in our recent release, users have asked us to put more data on the home screen. So in this case, the AQI, the air quality index value, is actually here, but you can see that in cases where the data is suspect or not, you're not quite as confident, it's actually fading out. So we're using translucency to indicate how confident you are about the data. So what Local Haze does is it crowdsources air quality data across just over 30,000 sensors. I think as of today, it was like 30,400 sensors over 6 continents, and it rates the data for accuracy and presents it in an easy to use user experience. So let's take a look. Here we are, we're going to start in San Francisco where the air quality is not that great. We're going to go across using the gestures on the iPhone and then zoom in with pinch and zoom into Boston. Now we're going to see there's a cluster of sensors. We're going to tap on it. We can see the sensors. We can scroll the list, and then we can drill down into a particular one. That's for Central Square in Cambridge. Why is this important? Well, air pollution and air quality is really important to your health. There's all kinds of headlines. There's a headline from this weekend about relationship to pollution and cancer. I read a lot about what's going on with, levels of air quality all over the world. And so it's a big issue. Particulate matter, or you might have heard it described as PM, is also important to understand because the small particles can get into your lungs and cause health issues. So this is a great diagram. It's available on the EPA website. This is a human hair. And you can see here, these particles are less than 2.5 microns or micrometers in diameter, and 4 of them can fit in one of these blue circles, and 20 of them can fit in the width of a human hair. So keep in mind that PM 2.5 number, because that smaller than 2.5 is what can get into your nasal passages and into your lungs, and that's something to understand. The smaller the particles, the deeper into the lungs these particles can go, and very fine particles can then make it into your bloodstream. So that's something to really be aware of. The air quality index, or AQI, every country has their own index. This is the US EPA AQI. It has levels where they are banded into index values that are considered, a qualitative explanation, satisfactory, acceptable, etc. We have actually taken this and collapsed it to make it a little easier for consumers, and I'll show you that. So how do you measure air quality? So let's take a look at some of the sensors that are used to measure this particulate matter. So the most expensive, or the gold standard, is called gravimetric. It's a batch process where you weigh air, you filter it, and you weigh it before and after the air is blown in. So you measure the weight of the air, the particles. There's something called beta ray absorption, or BAM, where you put a nuclear beta radiation through the air and you measure how much of it is absorbed. There's something called tapered element oscillating microbalance, which is a continuous system of weighing particles. There's also laser particle counting. This is the ones that we're seeing now in a lot of low-cost sensors that are deployed throughout the world, where you fire lasers through the air and you count the interruptions. The interruptions are the PM particles that are blocking the laser. There's also light scattering, which is how you measure visual haze at small scale. So top to bottom, these are the most expensive to the least expensive technologies. And I actually go all over the world taking pictures of air quality monitors. On the left are monitors in Toronto. On the right are the monitors, civic monitors in Austin, Texas. And you can see they're usually very large. They're protected. So in other words, you can't go close to them. They're usually got security around them. This is the one in downtown Toronto. You can see it's behind a fence, but it is on the street and it is sort of mobile. It's on a little trailer. But classic air quality monitoring for these government sensors, they're really expensive to buy and they're really expensive to operate. They require a lot of maintenance and they require regular calibration, but we do consider them to be the reference monitors because they are always under a lot of care and maintenance. Usually you see them at airports and embassies, but there has been a rise of low-cost particulate matter sensors. So you may have heard of the purple air sensor that's about $250, $300 sensor. It's got dual lasers. You can see them right here, the two lasers that are counting the particles. But there are also other low-cost sensors. Some of them are ones that you can wear and carry with you. Some you can do yourself. This is from Sensor Community. These are sensors that you buy for 35 euros or so, and you put it together yourself. And what we've done with Local Haze is we've created a basic data gathering IoT system where you have devices connected across the network, a database and an application server, data sent to the cloud, and this is the endpoint, the end user experience that we've designed to run on iOS. So the difference about Local Haze is that it aggregates several different data sources, low-cost sensors and those government sensors, Department of State sensors, and other, DIY and other low-cost sensors. Challenges in terms of designing for that is that you have these low-cost sensors, of which of the 30,000 sensors, you see the vast majority of them are low-cost sensors. So 16,000 Purple Air sensors, almost 12,000 Sensor.community sensors, many more than the government sensors. Now the reference for government sensors, you can see those numbers are much lower. But the point is, from a UX perspective, that wide range of data quality makes it a challenge because you have a large disparity in the volume and the quality of the data, and you have a lot of low quality data and a very small amount of high quality data. And you have to ask yourself as a designer, like, how do I design an experience where I'm allowing the user to understand where the data is coming from and to what extent should you believe it? So the UX presentation part of it is a very challenging thing. You have to communicate the quality of the data and not just the value. This is really what we're aiming to do here. We're trying to create something that at a glance is trustworthy. So you see the number and you see the AQI and you understand, because you see this badge, whether or not you can trust it. I'm not saying it's perfect. It's always been a challenge for us in terms of understandability and questions about, what the confidence rating is, but it is how we are trying to give the user confidence. We start with who is the user. That's the most important thing when you're designing these kind of systems. You have to understand who is your target user. If you have multiple target users or personas, you need to understand what's the priority. And in the first case with Local Haze, we started by targeting consumers that are also citizen scientists. These are people who care about air quality and are motivated. So like me, they may have received a diagnosis of asthma and they were told they had to carry an inhaler, and they really want to understand what's in their air. So this is an example of a persona template that I use. We used it when we went out and did our original user research to interview citizen scientists and other users to try to figure out what's our target user. And you can see here, they have certain frustrations and pain points, and they're motivated because they're really interested in being able to understand what data is coming from these low-cost sensors. And they want to know, can they actually read it and can they use it? They may have a family member that has a health problem. They may have frustration because they can't find the right sensor to buy. They have frustrations and pain points, and you really need to understand those well when you're going to design any kind of product, but especially a product like this. So the design challenges included presentation, not just the data and aggregating and scrubbing the data, but the actual presentation of it. As I showed you before, you have a wide variety of low-cost sensors and high calibrated sensors. And, scientists might expect an Excel sheet of data, but consumers want something that's at a glance, right? So this is not something for scientists who are expecting to be able to dig in to see all the data. This is something where we want to create a consumer quality experience. And in some cases, in particular, because this is iOS, there's a very high expectation for ease of use because of the underlying platform on which you're deploying the product. The expectations are very high for usability and for ease of use. Also, the interaction model, how the user actually expects to and interacts with and engages with the experience. We had to map the data into a really high quality user experience specifically for mapping. And then we also had to consider performance. So if the mapping part of the product was not performant, people would complain because they expect a high quality mapping experience. So before we go on, I'm going to give a little primer on interaction design so that we have a little interaction design toolkit before we start thinking about the design. And we're going to ask ourselves this question: what user experiences work best for dealing with lots of things, lots of entities? So in the case where you only display a few items, you could use an approach like this. You could just put one item on the screen. Maybe you have an index up at the top as shown here, but really it's about that one entity. But what happens if you have a list of many items? Okay, so we're thinking about larger scale number of entities. So in this case, you got 1,600 shoes. How do you display them for the user in a way that makes sense? Well, it's probably going to be a lot of scrolling. You could possibly use this kind of faceting approach, but let's just say you have scrolling. Well, you're going to need pagination. That's it's part of the design you could use. You could say I got 17 pages and the user has to flip through all those pages, or you could use infinite scrolling. So those of you who use Twitter, this is on the iPad, you'll see that the feed is just infinitely scrolling and scrolling and scrolling and scrolling. That's another way of dealing with lots and lots of entities, is to just put them in a continuous list and allow for infinite scrolling. Okay, another technique is called clustering. You may have heard this term. This is an example where you've done a search, let's say J. Crew, you're looking at all the shirts. It's all the same shirt with different colors. And that all of the colors are taking up the whole screen. You're filling up the whole screen with different colors of the same item. But the approach called clustering, you take a cluster or summarize the information and you make it presentable to the user so that at a glance they can see, and helps the user navigate to whether they want to actually drill down and look at detail in that particular entity. So with here's the dress, you can see that the dress is available in many colors. And you may decide, oh, I don't need to pursue that any further, or you might decide you want to look in more detail. That's called clustering. We also can use keyword search. So for example, the IRS website, you can do a search on taxes, but the results would be really overwhelming. You probably get thousands and thousands or tens of thousands of results. So you have to ask yourself, what happens when search fails to return a manageable number of results? What are the techniques that you can do as the interaction designer? Well, you really want to help the user search more precisely. So you might use what's called faceted search. Faceted search, here's an example. We've done a search on unicycles on eBay, and you can see the results list is here with a thumbnail, but these are the facets. These are the category tags of the search results. And you've got lots and lots of results, but as you choose facets, it actually narrows down the search results. So you're kind of winnowing down and decreasing the number of search results to help the user find what he or she is looking for. This is an example of faceting. It's just presented in a different way. This is Jira. And you can see these facets are presented almost like drop downs. So you're building a query using these interactions, a very different experience than the faceted search I showed you. And this is an even more technical looking faceted search. It almost looks like a query language. So these are all examples along a continuum of how you could do faceted search. And you could even build a query language if you wanted to, if you had the user who was interested in using that kind of searching technique. But if the user can't search precisely enough, what do? You have to try to organize the results in a way that makes sense. And one of those techniques is called progressive disclosure. Here's an example where the search results are for the unicycles, and we're presenting the search results based on the number of results, and in some cases, presenting the data differently based on the type of data. So if it's a lot of images, you can see here, there's a gallery of images, a lot of pictures of unicycles. So you present them in thumbnails with a navigation element here. Or if it's just text, you can put it as text, but you see that you're displaying the results differently based on the type of data. You could also sort by relevance. So for example, if you search for cafes and the system, in this case, Google knows where you are and that you've been searching for cafes that are open now, it can use dynamic relevance, which is an algorithmic technique to try to match the results to your interests or based on your user behavior. So there's a 93% match that you're looking for a particular coffee shop that's nearby and open it at the same time. Amazon works the same way. It can look at your browser history and then present information to you that you might be interested in, maybe before you've even started searching. So now that we've gone through that little primer, we have a toolkit of interactions for dealing with objects at scale, lots and lots of entities. Now with local haze, we're dealing with over 30,000 sensors over 6 continents. So that's a lot of entities. So when we talk about designing this iOS application, we have to say, what does scale mean? Scale is many thousands, in this case, tens of thousands of things, entities. It could mean millions of things, many, many things. That's what we're talking about right now for scale of entities. So that infinite scrolling technique that I showed you earlier, this is what we had when we first started with local haze. We just infinitely scrolled through, many, many, many sensors. And what happened was users complained. They said, I don't really like doing this. This is not a good user experience. And so to help manage that infinite scrolling list, what do? Think back to our primer, we added filtering. So the filtering allowed us to cut down those results list. It did put pressure on the user. The user had to know the actual tag or input text that they needed to use filtering, but it still helped the user cut down search results. After filtering, we said, okay, now what can we do to help the user actually winnow down their searching and make it more efficient? So for example, people ask for being able to pin a favorite sensor. So being able to look at the Toronto downtown sensor, this is this afternoon's air quality, it all looks good. And being able to favorite it so that it's always at the top of your list. So that's a form of helping the user to be able to navigate and to cut down on having to search their, to be able to see the data they want. So we went on and we added some more features. We listened to what users wanted and we said they wanted a map view. So we said, okay, let's put in a map view. We were a little unsure when we started about how to present it, but users wanted to understand the geography of the sensors and to navigate. And on the left, you can see our first release. It was not good. There were too many sensors. In particular, you can see these clusters, like really lots of sensors on the West Coast, especially because of wildfires that were starting to happen. What we had to do was we had to develop a clustering algorithms, like I showed you earlier, to be able to sort of summarize the number of sensors in that particular region at that particular level of scale, okay? We call that level of abstraction. In other words, what's the level of abstraction where you have gestured so that you are now at a particular level of scale? What's the right way to represent that data? And being able to represent a summary, the number of sensors with this little color band that gives you an idea of what the overall sense of the quality of the air and the breakdown is in that region. So that presentation challenge was really to understand how to do those clustering algorithms so that in this region, there are 12 sensors. You can see that the quality is not good among a lot of the sensors. And so you need to be able to know, like, how do you present that data to help the user make the decision if they're going to navigate. You can see here's like a really high level of scale. This is looking at North and South America. And then you zoom into Boston. This is today. And now when you look at a cluster, you can say, okay, I can choose a sensor, look at it, and then drill down and see that sensor detail. Now scale, we've been talking about scale of many entities. And typically in the case of local haze, we've been talking about geographical scale, a number of entities across a wide geography. But we're also going to talk about scale in time, okay? Now, what happened was users started telling us, we want to be notified about a particular sensor. I live in the Bay Area. I want to know if the air quality is degrading quickly because of wildfires. Do I have to close my windows? Do I have to take my kids in the house? So those are the kinds of use cases we were hearing and requests. And so we said, okay, we want to be able to notify the user about a particular sensor. Now, every sensor that I showed you has its own cadence at which it reports data. So the purple air sensors I showed you, they report data every 2 minutes. That's a pretty rapid cadence. Other sensors report according to a different time interval. And here on the right, I'm showing you the AQI representation with a kind of visual cue for the air quality and for the confidence rating. And so what we needed to do was figure out what was the best way to report that data in a way that made sense for the user. So you can see in the detailed view of the sensor, all we wanted the user to do is make a single gesture, the tap, to turn on the alert. And then the user starts getting notified as soon as the air quality has changed. Now, that's a good question, is what does it mean to change? What happened was, when we released this, we got this result, especially during wildfire season out on the West Coast. Lots and lots and lots of notifications happening very rapidly. And when we released a beta with 10 users, we were getting a lot of complaints. In the case of purple air sensor, remember that sensor is reading the data every 2 minutes. And anytime you have an AQI reading that's near the boundary of the index range, it oscillates back and forth across that boundary, and you get hit with so many notifications. And users were complaining. They said, we want to understand when the air is changing and degrading, but we don't want to get hit with so many notifications, so fix it. So that was a challenge, right? We got a lot of user feedback. We worked with our beta users and we listened to their complaints, and we started developing algorithms to do the smoothing of that notification by filtering the right way. So that's an example of scale in time. And it's an ongoing process of refinement. And any of you who work on these kind of projects know that it's not one and done. You're constantly having to listen to your users. You know, your personas may shift, your requirements may shift. You need to constantly be able to improve and satisfy what is needed in a good experience. The design challenges really were, what's the correct way to notify for a specific sensor? How is it, you know, how do you represent when there's too frequent? Like, how do you slow that down? And then a question, should the notifications be persistent? In other words, they stay on the screen forever until the user dismisses them, or are they ephemeral? They fade away after a certain amount of time. All good questions, all challenges in the design. So the lessons learned in this particular design challenge for monitoring air, we really understand the user's needs and journey. We really dug in, we really worked very hard to understand the personas and the journey, that is the kind of timeline for a particular use case, for a particular persona, is understanding how the user arrives at the product, in this case, the App Store, is onboarded and goes through engagement. And in our case, we actually added subscription after several releases. We added a subscription feature, so we changed the journey. And we were always monitoring those metrics to see that users were actually able to engage and start utilizing the data, using maps, and then eventually evangelizing. We had problems with our onboarding, for example. People just asked, like, I don't understand what that badge means. They were new to understanding PM. We had to teach them that. So, you know, think about your onboarding as something, an opportunity to educate your users and get them so that they're ready to be engaged with the features in your product. We maintained ease of use as a core attribute. We did not move on this. We got a lot of pressure to add more and more and more data onto the screens, in particular with people who seem to really want to fill up the screen with a lot of numbers. And we said, no, ease of use is at our core of our offering. Therefore, we want it to be glanceable, we want it to be beautiful, and we want to respect the white space. And oftentimes when you're the designer, you may be under pressure on the business side. You know, if you're responsible for the user experience, you have to be able to make the arguments for why it's better for the users. You have to look at, you know, what are the risks of making changes. We did actually take a suggestion, which was, we got multiple suggestions to put the AQI number here, but we didn't have it before. We had it actually one screen down, and we did make that change. You want to match the interaction model to the user's need, and don't be concerned about blending interaction models in a single unified experience. So in our case, we have a map. It uses gestures for pinching and zooming and panning. And now we also have an interaction model for using keyword search and scrolling. That's fine. And then drill down. So in other words, when you find a selection, you drill down. And then the way iOS works is you navigate back by hitting or tapping the back button. And I also want to stress that you want to solve for the applicable scale. So in some cases, you're solving for many entity scale. And in some cases, you're solving for temporal or time scale. You have to really know what's your scale you're wrestling with, thinking about the problem, and then coming up with your design solutions that will solve the problem. And I want to leave you with another thing, which is the trustworthiness of the data. We worked really hard to make sure that we were showing the confidence rating as best we could. We were being precise. So remember the purple air sensors have 2 lasers on them. So we're showing all the data from both lasers. So any sensor, we actually show all the data that we can in a way that's clear. We also show recency as part of our calculation for determining confidence. So in other words, if the data is really old, it's probably suspect. We also use transparency in terms of where the data is sourced. what's the location, you can see the lat long exactly, and also the type of sensor that is reporting the data. So all those things together, a kind of a collection of attributes, are what we are doing to try to increase the perception of trustworthiness. And if we look at the ratings and reviews, we've continued to add sensors. We're well over 30,000 now. It changes a little bit. Some sensors go offline in Europe, especially now. But we're seeing very large increases in downloads, especially around events like wildfires, which typically happen in August. This year, they're starting earlier. And we've maintained a solid 4.6 star rating on the App Store with a lot of comments that users write to me all the time, like the one at the right, where someone said, I was in Lake Tahoe and I used your product to help me understand the quality of the air. People have written to me and told me that they've used local haze as a form of an air quality compass. If they live in a recreational vehicle and they need to know where to go the next day, they use the app. So it's extremely gratifying to hear that. So that's my slides. I really appreciate you listening, and
This
thank
has
you.
been wonderful. Yeah, thanks for sharing your work and your process and all of the consideration that went into it.
Yeah, I'll be in Boston soon. Look forward to seeing everyone. Bye.
Okay, bye.